Now, value of the function. What is the meaning of the value of the functions? Definition is that the value of the function, suppose we have a function y is equal to function of x here, and the value of the function x is equal to denoted by f of a, and a value determined by putting x is equal to a in the functions. That is known as the value of the function that denoted by f of a. Suppose we have a function y is equal to function of x, and we are going to find out the value of this function at x is equal to a, that is denoted by f of a. F of a means value of the function at x is equal to a. How to find out? Just put at x is equal to a in the expression. So here we have given here f of x is equal to expression x square plus 2x plus 4. And suppose we are going to find out the value of this function at x is equal to 1 here. At x is equal to 1. So we have to put here x is equal to 1 in this expression. Put here x is equal to 1 in this expression. We have to put f of 1. We have to put x is equal to 1 square plus 2 x is equal to 1 and plus of 4, that is equal to 1 square plus 2 plus 4 is equal to 7. In the similarly, value of the function at x is equal to 3. What is the value of x is equal to 1 is equal to 3? That is denoted by f of 3 here. How to write? X, suppose here this is x square, it means 3 square. This is the 2 into 3. That is the 2 into 3 and plus of 4. That is the 3 square means 9 plus of 6 and plus of 4, that is equal to 19. So in this way, we can understand the concept of value of the function. What is the value of the function? We have to just put the expression at x is equal to a and denoted by f of a. So just put the value of x for the finding the results, and that expression will be value of the function at that particular point. So here this expression is written by y. Suppose we have the another example here. Suppose we have another example. F of x is equal to x square. This is the function. And what is the value of this function at x is equal to 2? What I have to do? We have to write the function at f of 2 and put x is equal to 2. And final answer is that here 4. In this way, we can find out the value of the function in this way. So okay. Now we have the different types of function. Already we are familiar with the concept, different types of function, but we are going to study here limits. So limits depends upon the function. We are going to find limits where limits of the functions. So we have to always aware with the concept of the function, aware the types of the functions. So we have the function of the type that is the algebraic and transcendental functions. Algebraic expression of the form of that is in which one variable is involved or more than one variable is involved. Yes, suppose the expression of the form x square plus x plus 5. That is an algebraic expression and it is known as the algebraic function. But in the case of the transcendental function, we have the algebraic expression as well as some other type of function. Suppose e raised to power of x or log x, yeah, some trigonometric functions. So that type of function, including this type of functions, will be case of the transcendental functions. In the same section, explective function and implicit function. Explective function is that one variable can be expressed in the form of other variables. And if this separation is not possible, that is not the implicit. Suppose here we have written here, suppose we have written expression of the form x square plus y square is equal to a square. Suppose this is expression. So from this expression, we can find out y is equal to under root a square minus of x square. Or we can also find out x square is equal to a square minus of y square. And value of x can be written in the terms of other variables and value of y can be written in the terms of other variables. So this type of separation is possible. That is known as the explicit or the implicit function. Suppose your expression of the form x raised to power 2 by 3, y raised to power of 2 by 3 is equal to 3xy. So this type of expression from separation of x is not possible here. So this type of function is known as implicit and explicit functions. Under we have the concept that is the even function and the odd functions. Before going to understand this concept of even and odd, we have to erase first it. We have to erase. Okay. What is the, so first of all, we have to know across the point that is the even function, that is the even. Even function means suppose we have function f of x. Suppose we have the function. If put here x is equal to minus x in the given expression and there is no change in the function. Means if we put x is equal to minus x and we have the result f of x. So the function is said to be the even function. And if putting x is equal to minus x, function have the same value but with a negative sign, the function is known as the odd functions. For example, suppose we have function f of x is equal to x square. Clear? If we put here, x is equal to minus x, what happened? X is equal to minus x, that is the minus of x square is equal to, that is the plus of x square, and it is equal to the same function here. Okay. So f of x square is a even function because putting exchange the expression with x is equal to minus x, there is no specific change in the given function. There is no specific change in the given function. So this type of function is known as the, this type of function is known as the even function. Another example for the odd function, suppose we have the function f of x is equal to x cube. Okay. And put here, put x is equal to minus x. We put here x is equal to minus of x. So what happened? We put here x is equal to minus of x. So we get minus of x cube. And that is equal to minus of x cube. And that is equal to a minus of theta function. So we have the result of the form. We have get the same function but with the opposite sign. So if the expression on putting x is equal to minus in the given function remains same, that function is known as the even functions. And on putting the x is equal to, replacing the x is equal to minus x, the function have the same but with the opposite side, then function is said to be the odd functions. So this is the resultants and this is the, some definition related to the types of functions. What is the meaning of algebraic? What is the meaning of transcendental? What is the meaning of expletive function? What is the meaning of implicit function? And what is the meaning of even function? And what is the concept of odd functions? So I think you have to understand this one. So moving forward to the definition of the limits here. What is the limits? That is the topic is over here to define what is the limits. Limit is the approach. Limit is the approach. So we have to give the first definition first of all, and then we discuss all the types of related terminology related to the term, in the concept of limits. In the mathematics, a limit is defined as the value of the function nearer the neighborhood of its domain values. Okay, suppose you're going to find out the value of x is equal to 1 and at x is equal to 1 function value is not by any way is possible to determine. So we have to give the nearest approach to find out the values. And that approach is the in the mathematical known as the limits. How it is useful we learn here. Limits are important in calculus, mathematical analysis, and used to define integral derivatives and the continuity. Because limit and continuity, those are the same topics. If you understand the concept of the limits, you can move next step to the continuity. If you understand the concept of the limit and continuity, move the next step to the differentiability. And you know the league all these topics, we move to the concept of the integral parts and derivative, different integral parts, and so on the application point of view. It is also used in the analysis process. It is always concerned about the behavior of the function at the particular points. For example, suppose we are going to find out the value of the functions. What is the meaning and what is the definition of the limits here? Before going to define the definitions, we have to come across the points. I'm going to discuss with you. Suppose we have a function here. Listen very carefully. Suppose we have a function y is equal to here x square minus of 1 upon x minus 1. This is the function. And I am going to ask, so suppose we have function here, y f of x is equal to, okay, x square minus 1 upon x minus, okay. And now I am asking with all of you, what is the value of the function? What is the value of the function at x is equal to 1? At x is equal to 1. What is the answer? Suppose we have function x square minus 1 upon x minus 1. And I am just asking, what is the value of this function at x is equal to 1? In the last previous slides, I have discussed with you how to calculate the value of the function at any points. You have to just put the values and the expression and find the resultants. How to find out the value of the function at x is equal to 1 points? Okay, suppose this is the line. This is the value of, suppose this is the 1. So what is the value of the function at this point? I'm just asking this one. What is the value of the function at this point? Okay, how to calculate this one? So what have to generally do? All of you just do that. Here we have to divide like that. So we have to put the value of here. Give the expression of a square minus b square. We can put here x plus 1 here. We can put here x minus 1 here. And we x minus 1. You cancel out this one. The expression is x is plus 1 here. And for at x is equal to 1, at x is equal to 1, we have to just put value of function is equal to 1 plus 1 and it's equal to 2. You say the at x is equal to 1, the value of the function is 2 here. What do you think here? This is right or wrong? It is possible or not? Because it's not possible, this process is not true. Because it does not happen. Because of it, that's it. When you put x is equal to 1 at this function, it is to take the form of this one, that is the 0 square. X is equal to 1 square minus of 1 upon 1 minus 1. Its denominator becomes the 0. Its denominator becomes defined in the form of undefined form. The expression, the function is not defined at x is equal to 1. And it's at the point the denominator of the function is 0. And always we have the rule of the different divisibility is that if you have any division going to do that, a denominator is going to be equal to 0. Division is not possible. Division is not, because division is the separation of the things in the equality. It is the definition. Separation of the thing, the equality. But we have to know divisions. We have to know some amount. So division is only if in the case its denominator should be the have the some positive quantities. We have the some positive. If not, division is not possible. So what is the solution for that one? We have to find out the value. So we have to, in that case, we have to do the nearest approach to the 1. We are not find the value of the function at x is equal to 1, but we can find out the value of the function very nearer to the 1. Suppose we are going to find a value of 9.999. That is nearby point is equal to 1, but not exactly 1. That is some difference between them, 1 and 1999. So when we move to the value of, when we are going to approach to the 1, the value of the function also tends to a values. And that value is known as the limit of the function. So the concept of limit is arises here. The following is that denominator should be the positive. So we directly can't do that. We divide the cancellation and put the value of that, like is not always true. It is not possible because division is, for divisibility, denominator should be the have the some positive quantity. Otherwise, division is not possible. So you have to know the concept about the concept arises for the divisibilities here. Okay. So this is the concept. Some students have the very much aware about the concepts. So we can understand the concept of limits. So how to define the concept of limits here? We move across the points. Why the limits? Why the name limits? Okay. It is always give the limiting of maximum value of the function very nearer to the neighborhood of its particular domain values. Suppose we are going to find out the value of at 1. In the domain of this one, we are going to find out the value from the right here from to the left. So we have the definition here. A real valued function f of x and a real number a is the limit is defined as limit of the function of the function. Limit of the function is given by limit of the function at x is equal to a is denoted by L. is that it is notation of the function. Limits, limit of the function, limits at the function when x is equal to a. When x tends to a, not exactly, it is written as x tends to a. When value of x approaches to a, not at a. That is the difference would be clear. It is x tends to a. When x की वैल्यू जब x 1 की तरफ हो, वेरी नियर टू द 1 हो, इन दैट केस फंक्शन की वैल्यू किस डायरेक्शन मूव करेगी, वो वैल्यू लिमिट्स होगी. Okay, so when x tends to a, the limit of the function tends to a is denoted by, in that case, is L here. So it is read as the limit of the function as x tends to a, x approaches to a is equal to the limits, and that is denoted as x tends to a is read as the x tends to a, x approaches to the a. So that the notation of the function is the, we are going to give the definition in mathematically form. A real valued function, a real number is L is said to be the limit of the function for any epsilon, for any positive quantity. There should be a positive number defined as mod of f of x minus L is less than epsilon. This condition should be the defined for delta positive. So in that case, we can say that L is the limit of the function of the given. So this is the definition, real analysis parts of this one. But we, in the mathematical approach, we have to just know the concept. What is the meaning of? We have to just approach to that points where the exact value of the function is not possible to find out. So we have to give the approach to that point. अगर हम उस point की तरफ अगर जा रहे हैं, तो हमारी function में किस तरीके से change आएगा, उसकी क्या limitations होंगी? That is the limits. Okay. So one is the existence of the limits. Existence of limits, we have the concept here. Suppose we are going to find out the value of the function at x is equal to 1, and this is the 1x is equal to 1 point. So approach to x is equal to 8 can be done from the left hand side also, and approach to x is equal to 1 can be done from the right hand side also. We can find out the value at right hand side also. So 1 minute, please. Just I was saying with you, if we can approach to 1 from the left hand side, and we can approach to 1 from the right hand side also. So two types of limits should be there, left hand side and right hand sides. Okay. So if the value of the function that approaches from left hand side to the number line, but that is denoted by limits of the function, limit of the function x tends to a from left hand side, and that is denoted by the function is limit is known as the left hand limits. And we approaches to the point from the right hand side, that is the limits x tends to a plus, that is also of the function that is denoted by right hand sides. So left hand side, if the limit of the function exists, if and only if its left hand limits is equal to the right hand limits. If the left hand limit is equal to the right hand limits, in that case, limit of the function exists, and value of that function, that would be the limits of that function. So approach to the points, it can be done in the from the left hand side, that denote with the left hand limits. We can also from the right hand side, so it will be the right hand side. So we take an example in next slides here, and we discuss what is the limitations and how the value changes when you approach to the point from the left hand side and then from to the right hand sides. Okay. So limit of a point. We are going to discuss a limit at a point. Limit of a function at a point is the common value left hand side and the right hand side if they coincide. Okay. We have an example here. Find the limit of the following function. Is that limit of the function here? Limit of the function x plus 5 when x tends to 3. x tends to 3. We're going to just find out. So given that x plus 5, the domain value is here 3. Let us assume the left hand side, the neighborhood values on the number line. Suppose this is the point is here, this is the number line here, and this is the point 3. So before left hand side, this will be the point 2.999, 2.98, 2.97, 2.95, and so on. And from right hand, I have the value 3.01, 3.10, 3.500, and so on the values. So from the left hand approaches and from the right hand approaches. Suppose here, when you put x is equal to 2.95, here put x is equal to 2.95, answer is our 7.95. When we put x is equal to 2.97, answer is our 7.97. When our value was 2.999, answer is what? 7.999. It means when we move from left to x is equal to 3 points. This is the point 3. And we move very nearer to the 3, value of the function also move to the 8. Very nearer to the 8. Suppose that's the value of 7.95 here. 7.97 is here, but here 7.999. That is very nearer to the 8. This is the some difference here of it. This is the, but here is the value very nearer to the 8. When our points tends to the very nearer to the 3, our answer is very near to the 8. And the same concept, we move from the left right hand side. We move to the towards 3 from the right hand side when x approaches to 3 from the right hand side. Suppose we have the value for x is equal to 0.005. In that case, what is the value of function? That is the 8.005. When we put 3.004, 3.00, suppose this is the 0.004, 005, this is the 0.004, this is the 0.0001. So here we have the value that is the 0.805, with the value is that 8.004 here, and we have the very nearer to the 3, that is the 0.001. Answer is also very nearer to the 8, that is the 8.005. So what we find the concept? When our approach is very nearer to the points, our value of the function is also very nearer to the sum points, and that sum point is known as the limit of that function when we move towards from x approaches to that points. This is the concept behind the limits we have to follow, and we have to know about the concepts. Also, just we have approaches here. From the C, we have C here. In the first 3 values of x approaches to the 0 from left, and vary approaches to the 8. And also from last 3 values of the x approaches from the right, and also in that case value approaches to the same point 8. In that case, on the sequence, when x approaches to 3 from the left hand side, when x approaches to the 3 when right hand side, and when x is equal to 3, all the values very nearer to the 8 are late. That is the limit value of the given function is 8, because left hand limit and right hand limit in it, both the case are here same. So the limits of the function at x is equal to 3 is here 8. That is the nearest approach of the function to find out the value of the function. So we have to think. Okay. We have some other direct methods to calculate the value of the functions. The direct method to solve the similar problem is as follows. Suppose we have to give the same problem is here. Limit of the function x tends to 3, and function is that x plus 5. So we have to just put the value x is equal to 5. We have to get answer here 8. That is the direct approach to the functions. Just we have to put the values if the answer is exact. But we have to case, in the case of the denominator should be the positive. The value should be exact at points. So if we are putting x is equal, this is a simple and genuine case is here x plus 5. Just we are going to same type of problem. Limit of x tends to 2, x plus 9. What is the value when x tends to 2? The x plus 2 means it tends to value to the 9 here also. Its value tends to 11. So when x tends to 2, function of value of the function tends to 11. So that is the limit of the functions. That is the limit of the functions. So in that way, continue the things. We have another example in the terms of the radians form here. We have given here most important parts that the consider the function f of x is equal to function is that f of x is equal to when the limits x tends to pi by 2 and function is that sine x. What is the limit of the function sine x when x tends to pi by 2? X tends to pi by. So what is the variance supposed to be the 1? That is the point 0, 0, 1, x minus 0, 1, pi by 2 minus 0, 0, 1, pi by 2 plus 0, 0, 1, pi by 2 plus 0, 1. Very for approaches from the right and approaches from the left. We approach to the points from the left and approach to the point from the left. So when approach from the left, value of the function is 0.9950. And we approach from the right, we have the value of the approach from the 0.9990 here. So we have the 0.9950, 0.9999 and approaches 0.999 and 0.99950. In that scenario, you can understand the concept of the limits here and discuss the concepts. Okay, this is the problem. So you can understand the concept. Now we take some different types of problem here to describe the limit concept of the limits in detail here. We have some other example. That is example number 3 here. Find the function where f of x is defined by that is the x minus 2 when x is less than 0, 0 when x is equal to 0, and x plus 2 when x is the positive. Here we have the tabulated value of x, f of x very nearer to the 0. Very nearer to the 0, this is the 0 point. From the left you move here and from the right you have to move here. From the 0 right and right, that is 0.00001, 0.00001 and so on. Either point is the minus 10000 and so on. So what is the approach? For the negative values of x, we can also write. For the positive values of x, we can also write here. From the first 3 entries of the table, first 3 entries, that is the entry number 1, entry number 2, entry number 3. We can see that the value of the function is decreasing to minus 2. Okay. When x is equal to minus 0.1. Value answer is that minus 2.1 because for when x is negative, the value of function is defined by x minus 2. So when we have taken the negative value, that is the point minus 0.01 and minus of 2, that is the minus 2.1. So answer is this one. We have taken another value of x, that is the 0.01 minus 0.01. In that case, value of the function is also given by the expression x minus 2 here, that is the minus 2.01. And we have taken another value of x, that is the minus 1001 here, and we also have the value minus 2.001. In the same scenario, we have taken the here from the last 3 entries of the table, we can see that value of the function is increasing from 2. We have taken the value 2.001, value is 2.001, 0.01, 2.001, 0.1 to have the value of 2.1 here. So what we find here, we take the value from left to right, that value is going to be changed here. We have to different scenario of the changes. Values in increasing order and values the decreasing order. We take the negative values, the values in decreasing order. We take the positive values in our decreasing order. That is the concept. So what they conclude here? So we have the some limits. I have to take in the some things, the concept behind like that. So value of the function in that case, suppose we have the two function, one function f of x, another function is g of x, and the limit of the function x is equal to a is defined, and limit of the function x is equal to a of gx function is also defined. So there's limit of their sum function. We have the sum of the function f of x plus g of x at the same limit is described as the limit of their individual sums. Limit of x tends to a f of x plus of limit of x tends to a g of x. In the same scenario is also applied to the difference parts. If you are going to take the limit of difference of two function f of x minus of g of x, answer is difference of their individual limits. Difference of their individual limit. That is the limit of x tends to a f of x and limit of x tends to a f of x minus of limit of x tends to a g of x here. Okay. Now we have the some other examples, another properties. Constant multiple law of limits. Constant multiple law of limits. When we have the functions and we multiply the sum constant and then we take the limits, the constant is taken outside from the limit functions. So k limit of the function x is equal to a also. Product of the limits. Product of two function limits at the same points is determined by the product of their individual limits. Individual limits. The limit of x tends to f of x into limit of the function f of x is equal to gx function at x is equal to e points. Now, in the same sequence, we have the some quotient law of the limits. Difference of the division of the functions. The difference of the ratio of the function f of x comma gx, they are individual ratios. Limits of x tends to f of x and limit of x tends to a upon g of x. Power law of the limits. Suppose we have a function where the power in the function f of x raised to power of n here. In that case, we have the limits of the function raised to power of n. Surds of the roots. For the roots of the limits, we have also taken the roots of the limits and limits of the polynomials and the rational functions. We have the gx and hx are the two polynomial functions. The limit of x tends to a gx is equal to value of the function at that point. Value of the function at that point. This is the expression for the results. We have some also examples. We have some also definition. Example of properties number 9 is the most important is here. We have the expression of the form limit of x tends to a in the power of x raised to power of n minus a raised to power of n upon x minus a. Answer is n a raised to power of n minus 1. That is the answer. That is the most important theorem and the properties of the limits which can be used directly from the function. And where in the beginning we have described a question of the form limit of x tends to 1, x square minus 1 upon x minus 1. This is the case of that form. So we can answer of this type of problem can be directly find out by this form, x square minus 1 upon this one. Also, we have some properties like that. We have some standard limits we have to remember for the answering the questions. That is the standard limits. What is the standard limits? Limit of x tends to a 0. E raised to power mx minus 1 upon x is equal to m. Limit of x tends to 0. A raised to power x minus 1 upon x is equal to log of a to the base of e. Limit of x tends to infinite. 1 plus a by x raised to power of is equal to e raised to power of a. It means is that limit of x tends to infinite. 1 plus a by x is equal to e raised to power of x. That is e raised to power of a. So this is the formula that is the most important. Limit of same sequence. Limit of x tends to 0. Sin x upon x is equal to 1. Cos x upon x is equal to 1. Sin mx upon m. Sin mx upon x is equal to m. Limit of x tends to infinite. Sin x upon x is equal to 0. Limit of x tends to 0. A raised to power of x plus b raised to power of x upon 2 is equal to root ab. Limit of x tends to 0. Cos x plus a sin bx raised to power of 1 by x is equal to e raised to power of ab. Limit of x tends to 0. 1 minus cos x upon x square is equal to e square by 2. That is some standard concept, standard properties that can be used in finding the solutions of the different types of problems based on the limit parts. Now we have to define here some indeterminate forms. Indeterminate form means where the function is not defined. Any function, I'm putting the values, either convert in the form of 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 raised to power of 0, 1 raised to power infinity, and infinity raised to power of 0. Such cases, we use the L-Hospital rule if indeterminate form is 0 by 0 or indefinite of the forms. So these are the sum form already discussed with you. When I put the values, when I put the value x is equal to of any particular functions and it converts of any of these forms, that case is the indeterminate form. Indeterminate form. And in the if the function indeterminate form, we have to use the L-Hospital rules. L-Hospital rules means we have to divide the function first, and then after we have to find out the solution for that particular things. That particular things. So what is the L-Hospital rules here? We have to discuss here. L-Hospital rule is a method to evaluate the limits of the indeterminate form such as the 0 by 0 especially or infinity by infinity especially. If the function converts in this of the form, you can apply the L-Hospital rules. L-Hospital rules can also be applied more than once because for the same function, you can repeat the things until we get not function not until the function converted into this form for the particular value of the function. You can apply this rule. Still, it is hold in any indeterminate form from every time of the applications. If the problem is out of the indeterminate forms, it can be able to apply the L-Hospital rule also. If limit of the function x is equal to a and limit of the function is 0 or in plus minus infinite, you can apply the things. So denominator should not equal to the 0. Denominator is going to be equal to 0. We have to apply the things. So we have to keep in your mind while apply the things and putting the expression, yeah, one by one steps, you have to continue the process until when the denominator is not equal to 0. Not equal to 0. Some important trigonometric functions. Limit of x tends to 0, sin x. Limit of x tends to 0, cos x. Limit of x tends to 0, 1 minus cos x upon x. Limit of x tends to 0, sin inverse x upon x. Limit of x tends to 0, tan inverse x upon x. Limit of x tends to 0, sin x upon x. What is the value? Suppose we are going to find out limit of x tends to 0, sin x by x. So if you put the value of x is equal to 0, sin 0 by 0, that is the 0, and 0 by 0, that is the indeterminate form. So what I have to do here? You have to put here limit of x tends to 0, sin x upon x. So what I have to do? Limit of x tends to 0, sin derivative of the sin x. We have to differentiate the thing. Derivative of sin x is equal to cos of x. And x have the derivative 1. So limit of x tends to 0 cos x. Limit x to 0 cos is equal to here value of 1. So answer is 1 here. That's it. Limit of x tends to 0 sin x by x is equal to 1. In the same sequence, limit of x tends to 0 tan x by x is equal to also 1. So this is the concept you can apply for the particular problems and particular types of things to determine the cases and discuss the problem here. Now we have the taken example that is the most important parts and you can read the things here. Question is that find the limits. We have to find the limits when x tends to 2. Question is that x square minus of 3x plus of 2 upon x square minus of 6x plus of 8. When you put here, what happened? We have to put 2 square minus of 2 into 3 plus of 2 upon 2 square minus of 6 into 2 plus of 8. So 2 square 4, 4 plus 2, 6, 6 minus 6 upon 2 square 4 plus 8, 12. That is the 12 minus 12. That is the case of the 0 by 0. When you put here, the problem convert in the form of the 0 by 0 here. So what I have to do here? We have to do things. We have to cross the common factors. So we can here discuss here to find out the factorization method in numerator and denominator parts. We have to take the numerator part, that is the x square minus 3x plus 2. What I have to do? Take the factor of 2 in such a way that sum is the 3. So we have to taken 2 and 1. So factor is that x minus 2 and x minus 1. I think you all familiarize this one. And also we have the denominator part, that is x square minus 6x plus 8. And also we have the factor x minus 4 and x minus 2. But in both the factors, what factor we find? X minus 2, x minus 1 upon x minus 4 and x minus 2. And here I have the limit x minus 2. This is the cancel outs because this is the common. So remaining part is that x minus 1 upon x minus 4, and put here x minus equal to minus 2, x equal to 2. So 2 minus 1 upon 2 minus 4, that is the 1 upon minus 2. Answer will be minus 1 by 2 here. And also we have what I have to do? You are going to apply the L'Hospital. What I have to do? It can be written in the form here. Limit of x tends to do. We have to just differentiate the numerator. What happened? 2x minus of 3 and differentiate the denominator 2x minus of 6 and put the value of 2. So here 2 into 2 minus 3 upon 2 into 2 minus of 6. So 4 minus 3 upon 4 minus 6, 1 upon minus of 2. That is the answer. So by the L'Hospital rule, you can also find the answer. Yeah, you can apply the method of denominator by equality of cancellation of the common factors methods. You can also apply by the factorization method. You can also apply find out the result by using the L'Hospital rules. In L'Hospital, you have to divide the numerator and denominator with respect to that and put the values until the denominator does not becomes non-zero. In that case, you can find out the values of the function. So answer is here given by minus 1 by 2. And after cancellation of this one, we have the value and put the expression. So answer is minus 1 by 2. Another we have the problem. That is the two most good things, that the rationalization of the function is here. You have to find the limit of the function when x tends to 2, root 5x minus 4 minus root x upon x minus 1. In this type of problem, first of all, we have to rationalize the function. What have to do? You have to multiply the given function by its rationalized concept. So we have to multiply the function root 5x minus 4. Here is minus, so we have to multiply by plus. So multiply the given function root 5x minus 4 plus root of x in both numerator and the denominator parts. So function is here. We multiply by this function both sides. So this is the form of a square minus of b square, a plus b and a minus b. So a square minus of b square, the 5, 4 minus x minus of x. And this is the simple x minus 1 function, and this is the another function. So we have just write in the form of this one. And numerator part becomes x minus 1, and here x minus 1 also. So cancellation becomes the result of the form of this one. And put the value of x is equal to 2. We have the direct result x is equal to 4 by 2. That is the 4 by 2. That is the answer is 2 here. So you can, by calculating the value, you can find out the answer of that one. So this type of function must responsible and useful to find out this. Before going to find out the limits of this type of function, we have to first rationalize the functions, and then after we have to use the concept of that things. So that is also good questions. And we have the another example of the question of the form here. If the limit x tends to 0, a minus nx tan x sin nx upon x square is equal to 0, whereas the n is a non-zero real number, a is equal to values. What is the value of equal to 1? So we have to use the concept. We have to done that concept here. Limit of x tends to 0, sin x by x is equal to 1. So this should be the equal. X by x should be the equal. You see the mx, this is the nx. So denominator also contain the value of nx form, nx type here. So we have to write in the form here a minus n, nx, so sin nx by x square. So nx upon this one, nx upon nx should be declared here. So we write in the form of here a n minus. This is the value is 1, his value is also equal to 1. So a is equal to n plus 1 by n answer. So just we have to put in the form of this one. If the limit of x tends to 0, sine mx by x, the answer is m here. So we have to missing the value m. We have to put like m and we have to multiply it by m here. So this answer becomes out of the problem and answer is here m. So this is the property already discussed in the earlier. This property have to use in finding out the solution of the given particular x. One more example is also given is here. And I think you can all of you do this problem in very well. So you have to all of you note this problem. Limit of x tends to 0, tan x minus sin x upon sin cube x. Sin cube x. So you all of you have to solve. You have to do what have to do here? Tan x. Tan x can be written in the form of sin x upon cos x. Okay. So we have to take the common sin x. Sin upon sin make the division 1. 1 minus cos x upon sin square cos x square. And we have to just simplify and use the results. So this question should be noted out by all of you. And try to do that in your particular in your homework problems. And if you find difficulties in solving, you can also contact in the next hour lectures. So this is answer is going to be equal to, in another problem is that x square minus 9 upon 6. This can be problem can be done by use of the L'Hospital rules. Because putting x is equal to 3 becomes 1 0 by 0. So what I have to do? Divide, differentiate 2x upon 1. That's it. Limit of x tends to 3. And 2 into 3 is equal to 6 is the answer for that one. Or you can make the calculations. Cancellation of this one, x minus 3 by x minus 3. Answer is plus 3 and the answer is done as 6. So when division denominator becomes 0, division factor is not applicable in that case. It should be understood, and this gives rise to the concept of the limits in that approaches. We have the limit very nearer to the dead points. This is the concept of the limits. So finally, we come across the point learning outcome appreciations. In this session, I have discussed with you details, concepts of the limits of the given function. We have also understand in here properties of the limits applied in various types of the different functions. And also we have conclude here concept of the various types of the function related problems. So this is the learning outcome appreciations. Any question from your side, you can drop it in our chat box. Okay. Some of the game have the different questions. All are doing well. So thank you very much, everyone. Thank you.